Welcome to the introduction and overview of Gloo Fabric. My name is Keith Babbo. I'm on the product team here at Solo, and I'm joined by Josh Pritchard on the Fabric engineering team. Josh has a great demo where he's going to get hands-on with Fabric, which we'll show in a moment. But before we go there, let's talk about how the Kubernetes market is evolving. A recent survey from the CNCF found that 96% of member organizations were using Kubernetes. So really, Kubernetes is becoming, ubiquitous in the cloud-native ecosystem. But when you dig a bit deeper into the usage numbers there, we start to see a very important transition happening, where in 2021, the majority of workloads running in Kubernetes were applications. We start to see more and more supporting services, things like databases, CI/CD pipelines, observability tools, and service meshes like Istio start to be deployed alongside those applications to support those use cases. And this is a really healthy transition, right? We're seeing more and more critical workloads running in Kubernetes. So let's look specifically at service mesh and why customers are deploying service meshes in Kubernetes. Security, so securing the communication between individual services in your cluster. Also, strong workload identity and the ability to use access and authorization policies between those services for zero trust architectures. Resiliency, the cloud's a dynamic environment, so services going up and down, using things like retries and circuit breakers to protect our services in these environments. Observability, like operational insights to understand and anticipate failures and problems in our services. And then traffic management, having flexible routing between services for things like canary upgrades and failover policies, and also routing in multi-cluster architectures as well. As we help customers realize these benefits with service mesh, we noticed 3 behavioral patterns that repeat over and over again. The first is the ability to discover Kubernetes services, APIs, individual workloads, being able to discover deeper into the infrastructure layer at the CNI layer. So understanding what the CNI implementation is, what network policies are defined at that level. Also discovering meshes like Istio instances installed in our workload clusters. Then being able to connect those environments. So setting up routing between services and doing that in a secure way to implement zero trust architectures, allowing for multi-tenancy to individual teams to isolate their workspaces from one another, and then extending that to multi-cluster. And then finally, using those that information, the services we've discovered, the connections between those services, to observe our environment, to gather metrics, visualize relationships in a network graph, do tracing across services, logging. So we generally see customers set this up and repeat this pattern over and over again: discover, connect, and observe. And one of the key benefits with Istio and Gloo platform is the ability to realize these benefits of security, resiliency, traffic management, and observability with a declarative API. And this API allows you to discover namespaces, pods, services, and endpoints in your individual Kubernetes clusters, connect those services, and handle all the translation to the underlying configuration. So that's like configuring IP tables for routing traffic, configuring ingress into your cluster, programming Envoy and the low-level config in Envoy itself, and things like access policies for security between services. And then finally, configuring the observability stack. So all of this communication, these relationships between services, being able to set up OTel pipelines for metrics and tracing and logging data, and then also the status of all the resources and the services, and piping those to the most popular technologies out there when we think about Prometheus, Grafana, and OpenTelemetry. All of this works amazingly within Kubernetes, and that's why we see Istio and service mesh as such a popular technology in this domain. But what about the other areas of application networking in most enterprises, specifically cloud provider services and VMs or virtual machines? How common are these use cases nowadays? So we see that like in the CNCF annual survey, that's of those 96% of users that are using Kubernetes, close to 80% of those users were actually running Kubernetes in the public cloud. And if we look at the breakdown of the cloud providers being used, we can see that this adds up to way more than 100%, which means that these users are deploying not just to one cloud provider, but they're using Kubernetes in multiple cloud providers. Even more interesting is that when these users are leveraging Kubernetes in public cloud, they are also taking advantage of other ancillary services in those cloud providers, serverless being the number one most common service they're using. So if you look at, for example, of customers that are using Kubernetes in AWS, close to 75% of those users are also using a technology like Lambda or Fargate for serverless workloads. Now let's talk about some of the challenges you might hit when deploying to these cloud providers. The first is configuration sprawl. So there are a lot of fine-grained, low-level network engineering APIs that need to be configured even for basic end-to-end use cases, things like route tables and security groups and inter-VPC routing, hosted zones, DNS records. These really start to add up. What's worse is that the fundamental concepts involved are similar between cloud providers, but the APIs are all different. So as soon as you're going to go to multi-cloud, you're learning these APIs from scratch for each cloud provider you're targeting. And that makes it really hard to establish consistency and best practices and reference architectures in a multi-cloud environment because your setup might be quite different between cloud providers. And this can add operational cost as your teams struggle to scale to adopt these services across cloud providers. In addition to the cloud provider's native services, we also have to think about how virtual machines factor into our application networking strategy. We talked earlier about how Kubernetes is ubiquitous and 96% of organizations are adopting Kubernetes, but only 15% of those organizations have actually moved everything to Kubernetes or are running exclusively in that environment. Over half of those organizations have a combination of Kubernetes and VMs in their environment, which means for most situations, for most end-to-end use cases, you're going to need to connect those VMs to your Kubernetes environment. Now let's look at some of the challenges associated with integrating virtual machines in your application network. The first is around identity. There's no uniform approach to establishing the identity of a workload in a virtual machine across cloud providers and on-premise environments. This creates a big problem around credential management. So how are we setting up the identity tokens and certificates that are used by these virtual machines? And then what level of operational complexity is associated with managing those on an ongoing basis? The initial setup of that can be very complex, and then the operational cost of maintaining and refreshing those tokens over time can be a significant burden to teams, and sometimes a big security risk if the refresh interval is very long. So zooming back out, we recognize we're going to be in a hybrid environment here. We're going to have Kubernetes, we're going to have cloud provider services, and we're going to have virtual machines. How do we realize these common behavioral patterns of discover, connect, and observe across these disparate environments? And that's exactly what Gloo Fabric solves. Cross-cloud discovery, connectivity, and observability. We think of Gloo Fabric as a programmable application network for any cloud and any workload, using cloud-native primitives that behave like the service mesh you use in Kubernetes today. Specifically, Gloo Fabric allows you to discover VMs and cloud provider services running outside of Kubernetes. This works across cloud providers and is inclusive of on-premise environments as well. Once discovered, Fabric can connect these networks and workloads across cloud providers, generating the low-level network configuration so you don't have to handle that. This allows you to implement things like workspace isolation and zero trust across workloads and cloud providers, also supporting flexible onboarding workflows for virtual machines using agent or agentless approaches. Finally, Fabric allows you to observe this complete environment across cloud provider services and virtual machines, giving you deep insights into network and workspace boundaries, allowing you to view relationships between services and explore metrics and health information for those workloads in a single dashboard. All right, now it's time to see all this in action. Josh, take it away with the demo.
Thank you, Keith. All right, before we jump into the demo, I want to give a brief overview of what we're actually going to build out and the functionality we're going to demonstrate today. So I already have a couple clusters set up for the purposes of this demo. I have one in AWS and one in GCP. Inside each of these clusters, I have a pod running, just a normal workload, normal Nginx workload, and then also, in each VPC on the same private network, I have a VM running, one in AWS EC2 and one in Google Compute Engine. Then down here, I have another VM running in a separate VPC. For the purposes of this demo, this VPC has been connected through peering to this AWS VPC, but it's meant to demonstrate more of an on-prem environment because there's nothing else running here. There's no supporting infrastructure like another cluster, and it's only connected via network to this VPC, which is something you could do similarly with an on-prem system if you used a VPN gateway or something of that sort. Jumping into the demo, before I even get any of this traffic flowing, I first am going to show how we discover cloud resources. If we jump over here to the UI, we can see it says no networks found here and our cloud resources graph is empty. That's because we don't have any cloud providers configured yet. This is a Fabric-enabled workspace, so it's counting on some cloud resources to be discovered so we can associate the networks with the clusters that are already registered. Let's jump over and see what that looks like. So here I have a AWS cloud provider that I've configured. And then down here, I have a G Cloud one I've configured. Basic information like the account ID is really all I need here. Permissions are passed into our agent via roles. So these have, so that our agents running on each cluster have permissions to be able to discover information from each of these cloud providers. On AWS, I'm discovering EC2, which is really all that's used for the purposes of this demo, along with Google Compute. But I want to demonstrate that we also can discover some other aspects. So I'm going to apply these. And we should see our resources populate here pretty quickly. All right, great. So we have our GCP VPC showing up. We actually have the VPC from our management plane showing up too, and we haven't registered that cluster as part of Gloo Mesh. It's just a Kubernetes cluster standing on its own. And then we also have a workload cluster registered in our AWS VPC here. If we click into this, we can see more metadata associated with our cluster. In addition, we also are now going to see cloud resources over here, and we're having all of our VMs show up. So before we actually get any of these just VMs into the Fabric, what we first want to do is apply virtual destinations to get our KS pods first available to the Fabric and just get some traffic flowing to populate our graph. In here, these are some pretty standard virtual destinations for our system. We're just selecting services. This is how it would look today. The only notable difference is that I also have this Fabric global suffix on this host. And that's because right now, this Fabric global is our default Fabric name. And if that is on the suffix of any virtual destination host, even if it's a KDS workload, it'll make that available to our Fabric. So I'm going to jump over here and apply these. And then once those are applied, I'm going to get some traffic started. And I don't want to go to the VM yet because we haven't set that up. I want to go to the workload that I just set up. And right here, you can see I'm connected to workload GCP KAS. So I'm on this GCP workload connecting to the AWS workload. There we go. So curl. Nice. While we're waiting for that to populate, let's talk about what's populating for a second. So now that that traffic is flowing, our metrics pipeline, which uses OpenTelemetry, is collecting the Istio data and sending it up through our metrics pipeline so it can be viewed in our graph here. Now, what's Fabric is adding is all of this network information, and we actually merge that inside our OpenTelemetry pipeline with custom processors that we've made to merge in the network information, and which should allow it to be viewable in our graph here. So now, even though these are regular K8s clusters, we're getting extra information in the form of our VPC wrapping the workloads in these clusters now, and we can see they belong to this network. You'll notice another VPC kind of floating up here because there doesn't have any traffic flowing yet. That'll come into play later in the demo. So for the next step, we are going to bring in a VM in the AWS VPC to the Fabric. So let's go apply virtual destination to do that. And I also want to show that this ID, the KGEB resource, is available in the Cloud Resources tab, and that is, you can see that in my virtual destination configuration here that I'm about to apply. I'm naming this host workload AWS VM, and the application running on it is on port 80. Again, this VM is not running any type of agent. It's running a very simple Nginx server that is just going to reply on port 80 and nothing else is on the machine. So let me apply this. There we go. And from now, that VM, which I'm connected to over here, workload AWS VM, that I have SSH2, I am now going to start a curl to the AWS KS virtual destination that I set up before. Nice, so that is working now. And if we head to our graph, we're going to see that pop up in here in a second. Awesome. So now we can see we have an AWS instance that's part of the Fabric now. Let me organize this a little. Great. So to explain this, now we can see our instance is communicating directly to this AWS KAS workload. It's doing this through the Fabric gateway. We've added a gateway to each of the clusters in this setup, and because Fabric requires a gateway running on the private network. This theoretically could be combined with your normal ingress or east-west gateways. But if those, in this case, those are running on public networks, and this traffic, the Fabric gateway is always required on a private network. So this is pointing to the Fabric gateway because the DNS entry that we're now curling is always pointing to this IP. This Fabric gateway then has the configuration to send the traffic to the workload on the AWS cluster. Awesome. So also with this virtual destination, we're going to be able to get another form of traffic going, which is this Google pod to the VM in AWS. So let's apply that. So here I'm kexec into that workload on GCP. And let me curl this AWS VM. Awesome. Hello from workload AWS VM. So over in our graph, let me change the refresh. Over in our graph, we're going to see this new workload pop up in a second. And you're going to see a bit more infrastructure get highlighted. There we go. Let me move this over. Great. So now we can see an east-west gateway pop up here. And that is because the east-west gateway is where this workload has to reach out to reach this cluster securely, and then that can reach the instance. So to get a little more specific about how the traffic's actually flowing here, this piece is MTLS directly with this workload, because this workload has a sidecar, right? So this can talk securely to this east-west gateway, even though this is over public network. And then the east-west gateway can terminate that TLS and talk to the instance through plain text HTTP. Now, why we're not seeing the east-west gateway in this line here when we were talking directly from the GCP workload to the AWS workload is because it's using a different way of forwarding. So in this case, we have TLS termination, so this registers as a completely separate hop. In this case, the east-west gateway is still sitting in the middle of this traffic here, but it is using TLS pass-through. So that way these resources can authenticate with MTLS directly, which is leading us to not demonstrate or show a hop in the middle. So the next part we're going to enable is going to really show off the full network path that Gloo Fabric enables, and that is from this VM to this VM. And they're going to talk securely by leveraging the Kubernetes clusters here that are part of Gloo Mesh. In order to do this, we're going to add a cloud resource, and we can actually see the GCP workload that we're going to add right here. I have this name specified in the virtual destination here. So this virtual destination is going to be called GCP VM. And I'm going to be just selecting by name this GCP workload. One small thing to add is we don't have to select these by names. We can use labels in GCP, and we can use tags in AWS. All right. So here I am connected to this AWS VM. And I'm going to curl that GCP VM. Now, we're going to see this isn't working yet because I haven't applied the virtual destination. So apply that. Awesome. If we come over here. Yep, there we go. Hello from workload GCP VM. And if we go back to our network graph, we should see the data populate here shortly. In addition to just the new workload and VM that we'll see pop in, we're going to see some more infrastructure light up in this GCP cluster here, because this really has the exact same infrastructure as this EKS cluster. I set these up exactly the same. They both have a Gloo Mesh agent installed and the same installations of Istio. So awesome. So we just saw this new network flow pop in, and we can see that we are going all the way from our AWS instance through the Fabric gateway, through the east-west gateway, and then to our GCP VM. Now, to explain the hops here a little more, this is just talking over regular plain text HTTP to the Fabric gateway here. This Fabric gateway is upgrading the traffic and then using MTLS to speak with the east-west gateway securely over the internet. So these can talk even though they aren't connected via private network. And then the east-west gateway over here is terminating TLS and talking directly with plain text again to the GCP workload. All right, the last thing I want to demonstrate today is a VM connected to simulate an on-prem use case here. So as I mentioned before, there's no supporting infrastructure here, but this VM is running a agent that's running a sidecar effectively, and that sidecar is connected to ECOD through the Fabric gateway in this AWS cluster. As I mentioned before, the networks are set up to be connected here, but other than that, that's all you need. You just need a network connection, and so this could easily simulate on-prem environments connecting up to a cluster you have running up in a cloud. And this doesn't even have to necessarily be a private network, because this is using MTLS to open a connection with the Fabric gateway here. So you don't have to worry about any traffic being insecure. Now, I already have this like set up and added to our system. So, and I'm SSH to this like on-prem workload over here. So all I really need to do is start curling, and I'm going to reach out to the GCP VM to demonstrate again the full path of us reaching out from a VM in AWS, leveraging that AWS infrastructure in our cluster to talk with the cluster in GCP and eventually reach the GCP VM. Over in the graph here, we should see our new workload populate in this VPC that's kind of been sitting over here empty until now because it didn't have any traffic flowing into it. There we go. Let me move that. Awesome. So now you can see this instance right here is reaching in and to this cluster through the Fabric gateway. And the reason, again, we don't see this hop through the Fabric gateway here is exactly the same reason we don't see that hop here, because this is using TLS pass-through on the Fabric gateway that's sitting on this cluster to communicate with MTLS directly to the east-west gateway. Then the east-west gateway is terminating the TLS connection and talking with the GCP workload with plain text. So yeah, this demonstrates all of what we wanted to show you Fabric today. And I hope you enjoyed the demo. Thank you for listening.